number 3, proving theorem 1.2. And here, basically, with theorem 1.2, this theorem establishes the familiar properties of negative numbers. And basically it states if a is a number, then minus a negative a equals to a. Well, we know that, but we're going to go ahead and prove it. And then 2, if a and b are numbers, then negative parentheses a plus b is negative a plus a negative b. So the first one, if a is a number, then minus a negative a equals to a. So the first thing that we do is we start with a plus x equals to 0, because if we can show that because we have a negative and a positive, right, then it seems to reason that the two of those together, a and negative a, would equal to 0. Okay, so we start with a plus x equals 0, and this is basically axiom A.5, existence of a negative, where if a is any number, there is one and only one number x such that a plus x equals 0. So this is axiom A.5, existence of 0. Okay, and then what we can do is we can say, all right, well, let's apply a negative a. So if we were to say we substitute negative a in for x, existence of a negative, and then we multiply negative 1 times negative 1 times negative 1 times negative 1. And basically we're just multiplying negative 1. So that gives us a negative a plus minus times a negative a equals, well, negative 1 times 0, that's still just 0. So minus a negative a is a positive a, so this is negative a plus a equals 0. And from here, minus a negative a and a positive a, that's 0. And so that holds. Thus, we can say that a plus negative a equals to negative a plus a, which equals to 0. Okay, and then the second one, so basically we're going to do the same thing we did here, but now we're going to use a plus b. So given a plus b plus x equals 0. So instead of a plus x equals 0, we're using a plus b because that's what we're trying to prove in the second part. So now we're going to take this negative a plus b and substitute that, we're going to take this and substitute that in for x. So that'll be a plus b plus a negative a plus b equals 0. And so now we're going to go ahead and distribute that negative a plus b plus negative a plus negative b, distributive property. And then we're going to regroup these. So basically, we flip b and a, that would be a commutative property. A plus a negative a plus b plus a negative b. And well, now we know that if we group these together, a plus a negative a, and then b plus a negative b, a plus a negative a, that's 0. And b plus negative b, that's 0. And so 0 plus 0 is 0. And so it holds. So in these two and proving theorem 1.2, we started with this a plus x equals 0. And then we substituted in the opposite and worked from there. Here we, instead of a, we put a plus b plus x equals 0. And established an equation to start with. And that is our theorem that we have proved.